Mainly classified, isomerism mainly classified into structural and stereo. Structural, there are 5 types: chain, positional, functional, metamerism and tautomerism. So tautomerism we did, right? In case of hyperconjugation, next alpha hydrogen will be there. In that we did some. And who were there in my first class? Anyone? Raise your hand. First class 1 month before I have taken isomerism. Who were there? Only you two. That's all. That is online class, I think. Right? Anyone is there? No? Okay, chal. I will repeat it tomorrow in the same class, and video also is sent. So now, stereoisomerism is again classified into 2 types: conformational and configurational. Conformational and configurational. Stereoisomerism is classified into 2 types: conformational one and other one configurational. This configurational is again classified into 2 types: geometrical and optical. I'll tell one by one what is it. So this classification is also not unique. In other books they will tell geometrical only, they will consider some of the optical isomers. So this is one of them. So geometrical again classified into 2 types: cis-trans and EZ. EZ means what? N-tech and Zusammen. EZ isomerism and cis-trans isomerism. Optical, there are enantiomers and diastereomers. So this all we will see now. So I will discuss the structural isomerism part later. Okay. We will see now stereoisomerism part, that is conformational and configurational. So today I will discuss these 2 things. Optical again. So what is stereoisomerism first of all? Stereoisomerism means what? Stereoisomerism means same compounds having same molecular formula, but spatial arrangement of the atoms will be changing. Spatial arrangement of atoms changes. Spatial arrangement of atoms will change. Okay. So we will start first conformational isomerism. Okay. Next configuration. Conformational isomerism or conformational isomers. What is the definition of that? Compounds having same molecular formula, okay, but different spatial arrangement of atoms due to carbon-carbon free rotation. Carbon-carbon single bond free rotation means the isomers which are formed due to the free rotation of carbon-carbon single bond are called as conformational isomers. The isomers which are formed by free rotation of carbon-carbon single bond, okay, are called as conformational isomers. The isomers which are formed by free rotation of carbon-carbon single bond. Means carbon-carbon single bond, if we rotate, means we don't rotate. If we give some energy, they will rotate it on its own, and we will have different types of isomers. Some infinite number of isomers will be formed, infinite, due to CC rotation. In that, 3, 4 we will identify. Okay. These are non-separable. We cannot isolate them. These are non-isolated. Means they are interconvertible. These are interconvertible. Okay. So these are also called as rotamers. Why? Rotational isomers. Rotamers. Rotational isomers we are combining. Conformational isomers are also called as rotamers. Rotational isomers. So generally exhibited by alkanes and even cycloalkanes also. Generally alkanes will exhibit conformational isomer. So this is also simple question they can ask. Which of the following compounds undergoes conformational isomers? Alkanes, alkenes, alcohols. Generally alkenes will exhibit. Even alcohols also. Alkanes, cycloalkanes, alcohols, alkyl halides, saturated ones. Okay, please you can tell. But mainly saturated compounds, etc. Now, here we should know some basics about this. A three-dimensional picture can be written in two-dimensional form in 4 ways. A 3D picture can be written on 2D picture in 4 ways. What are those? First way is Sahar's projection. Understood? Next one, wedge method. Right? Next one, Newman projection. Newman projection. And next one, Fisher method. Fisher projection. So a 3D picture can be written in a 2D method in these 4 methods, 4 forms. Sahar's projection means what? That Y and inverted Y. Like this you have seen now. This is called Sahar's projection, eclipse and all. Wedge method. Wedge method means one will be in the plane of the board. This is thick line and this is dotted line. Have you seen? Thick line means what, children? Thick line means, bold line means wedge bond. Wedge bond you will say. This is towards the observer and this is away from the observer. Means suppose this V is on the plane, this wedge one will be towards the board. Means it will come towards you. Dotted means back of the board. Back side. Like that. V shape. So if the board is the plane, this is towards the observer and that is away from the observer. Fine, and making it simple. Afterwards we will do conversions also if time permits. Next, Newman projection. Newman projection means what? This one. So first carbon you have to take it as dot and rare carbon, this is called front carbon, and back carbon you have to represent with circle. So this is Newman projection. Dot and circle method. Right? And Fisher projection, simple I am telling you, just to have an idea. Fisher projection, what you have to do? The longest chain you have to take it in a Fisher projection. Only three sentences will be there. The mother chain you have to take it as a vertical line. First sentence, Fisher projection. Mother chain should be taken in a vertical line. Suppose I am writing this tartaric acid form, tartaric acid. So how to represent this 3D picture into 2D? Mother chain take it as a vertical line and top high priority group should be there. Here both are same. Suppose it is CH3, you can write down CH3. Okay. After that, number of branches are represented with a horizontal lines. Number of branches are represented with a horizontal lines. The intersection between the horizontal and vertical line is a chiral carbon. Understand? So 3 points in Fisher projection. First, what you have to do? The longest chain take it as a vertical line. First point. Longest chain take it as vertical line. And top you keep the high priority group, bottom you keep the low priority group. Suppose here a CS3 is there for our instance, example. Then CS3 will be here. Understood? Next, number of branches you take it like this. Horizontal line. Number of branches are represented with horizontal lines. And the intersection between vertical and horizontal line will gives about the chiral carbon. How many chiral centers are there like that? Okay, you can write anyway. 4 forms will be there. I wrote one of the form. I have written one of the form here. Suppose you want to represent glucose, how will you represent? So CHO, CH2OH, 6 carbons are there. So this is the vertical line. And 4 are branches. So 4 horizontal lines. In that the third line OH will be on the left hand side. That is called glucose because you will get 16 isomers. In that one of the form is this. So this is the representation of glucose in Fischer projection. Are you understanding? Okay. So in that, for conformational isomerism, we will take a Newman projection. Okay. Right. So let us take some examples. So I will explain the conformational isomers by taking butane. What I am taking? Butane. Butane. What is the formula? C4H10. And what is the structure? CH3, CH2, CH2, CH3. Right, children? 4 will be there. So in that, I am taking second carbon and third carbon. Front carbon you can take anyway. Second carbon is this dotted I am telling, dotted I am taking. So for this carbon, what are there? This is C2 carbon, C2 and C3 you can take. 2 then 3. Okay. So for this, what are the groups, children? One is CH3 and 2 are hydrogens. See, this is CH3 and this is hydrogen and this is hydrogen. This is the front carbon. Are you understanding? For this, one CH3 group is there and 2 hydrogens are there. And for the third carbon also same thing. So I am taking it as circle. One is CH3 and 2 hydrogens are there. Like this I will take. The intersection between the dot and circle is this bond, children. The intersection between the dot and circle is the thick bond. Are you understanding? So shall I give the numbering now? This is 1, this is 2, okay? And this is 3 circle and this is 4, like that. 1, 2, 3, 4. Okay? This is the first carbon, CH3. Second carbon I have taken it as dot. And third carbon I have taken the circle, that is rare carbon. Rare carbon means back carbon. This dot is front carbon. Understanding? The circle is back carbon. Understanding or looking like Malayali movie? Okay. Now, fourth carbon is at CH3. Right. So, this form is called as staggered form. What is this form you say? Staggered form, or you can say anti-staggered form. Okay. Here the angle between this CH3 and this CH3 is 180 degrees. Okay. This is called as dihedral angle. Dihedral angle. It is not normal angle. See, suppose here like this is there. The angle between this carbon and this carbon, we cannot check like this. Suppose my hand is one carbon you take and this is one carbon. This angle is dihedral angle. Okay, it is not like a normal B angle. So dihedral angle is 180 degrees. Now, this form is, see CH3 here and CH3 here are there, no? So repulsions will be less, children. Why? Because they are far from each other. Repulsions are less. Right? And this is the more stable form. Why? Because both the CH3s are far from each other. Now, if I rotate 60 degrees in an anti-clockwise direction, okay, then what isomer you will get? If I rotate 60 degrees anti-clockwise direction, so front carbon I am keeping the same, but back carbon I am rotating in an anti-clockwise direction. So what I used to get? Front carbon CH3 H will be like that only. That is the front carbon. But back carbon I rotated to how many degrees? 60 degrees I rotated. So the CH3 will go here. See, this is CH3, back of it, and here H will come, and one here H will come. So how to write that structure? First write like this, next circle keep like this. You remember. Next. So this is that eclipse. Here of course partial eclipse will come. Understanding? If I rotate 60 degrees, that is the structure I am going to get. I rotated the back carbon by giving some energy. Rotate means we cannot rotate with hand. Okay. Just if you give the energy, it will convert into other form. Now this is called partially eclipsed children. What is this? Partially eclipsed form. Partially eclipsed form. Right? So this I am erasing. Afterwards we will discuss. Let us write all the forms. So this is called partially eclipsed. Why I told partially eclipsed? Because back of H, CH3 is there. CH3 size is bigger one and hydrogen size is smaller one. So hydrogen cannot cover all the CH3 because it is smaller size. No. If both are CH3, then we can see only one CH3 from front because other will be covered. Right? See, two persons are there of the same height, one on back. Then we can see only one person. No, we cannot see the back person. But if one is shorter one and one is taller one, then we can see the taller one also. No. But he is back of it, you can see at least the face up to some height you can see. Right? Here also, one is hydrogen, one is CH3. We cannot completely shade, but it will be seen to some extent. Next, if I rotate 60 more degrees, then what you will get? See, this is the front carbon, CH3, H. After that, we will get here CH3, H. So this form is called as gauge or skew. Gauge form or skew form. Okay? Just the angle if you want you can write. This angle is 180 degrees and here the angle is between CH3 I am talking about 120 degrees and here the angle is how much? Again 60 degrees. Fine, between two CH3s. Now, if I rotate 60 more degrees, then what happens? This is the front carbon, CH3, H. Now that CH3 will go back of it, CH3, just imagine children, H and H. So this is called fully eclipsed confirmed. You know this, just and this. So here theta will be 0 degrees. Okay? So this is called staggered form, 180 degrees. This is called partially eclipsed form. Staggered, you can say anti also, anti-staggered. Next we will get gauge form or skew form. Next one will be fully eclipsed. So, if I rotated 60 more degrees to that, here only. If I rotate to 60 more degrees, then which isomer I will get? Can anyone? See, front carbon I am not changing it. That is why I am writing as it is. But back carbon 60 more degrees. So the CH3 will come here, H will be here, and H will be here. So this is again you got a skew form or gauge form. And last 60 degrees if you rotate, then what happens? Again 60 degrees I am rotating, anti-clockwise only. So I will get Which isomer can anyone tell? If partially eclipsed, very good. So you will get again partially eclipsed form. So last 60 degrees, you will get a staggered form. Like this 360 degrees, if you rotate, you will get these isomers. Once again you see, easy. First I have taken the staggered form, 60 degrees I rotated, we got a partially eclipsed form. Next again I rotated 60 degrees, that is called as gauge form, in which both the CH3s are at 60 degrees, that is gauge. Next 60 degrees if I rotate, you will get fully eclipsed form. Next one more 60 degrees if you rotate, again a skew form is formed. So now I will write the structures, I will name them. 1, structure number 1, this is 2, this is 3, it is 4, this is 5th structure, and this is the 6th structure. Actually infinite number will be formed, but somewhat identified are this, somewhat stable. If you rotate CC bond, infinite number of isomers will come. Among them some are this. Staggered, partially eclipsed, gauge, fully staggered and skew. Here also this is what ma? This form. Partially eclipsed only, no? Partially eclipsed. EC. Partially eclipsed. Eclipsed. Eclipse, solar eclipse, lunar eclipse, you will see. Sun and moon will back up. Okay, now if you take the stability order of this, which form is more stable, and energy form, this they will ask. Okay, so I am talking about now stability forms. Stability, can anyone say which is more stable, children? First one, staggered is more stable generally. After staggered, skew form will come because somewhat distance is more. After skew, partially eclipsed will come. After that, fully eclipsed. So this is the stability order of these isomers. Okay, staggered, skew, partially eclipsed and fully eclipsed. Energy will be reverse of that. Energy order will be reversed. So can we say here which is more stable among them? First one is more stable. After that, what are the skew forms? 3 equal to 5. Right? 3 equal to 5. Because those two are the skew forms. After that, partially eclipsed, what are those? 2 and 6. Next, finally, you will get fully eclipsed, that is our third isomer, fourth isomer. See once. Understanding? This is about the stability order. Energy order will be opposite. So what is the energy order, children? Just I will write normally. Energy order will be fully eclipsed, greater than, partially eclipsed, greater than, skew or gauge form, next anti-staggered form. This is the energy. But for everything it is not same. For every molecule it is not the case. Right? If you take 1, 2 diols or like that, then the structure will be. Shall I erase? So they will ask why fully eclipsed is least stable means. What do you have to say here? One point is there, one question they will be asking. Here there are 3 types of strains. That is important. What are those? CH3, there will be a steric strain because of bulky groups. Steric strain. Okay. Between these bonds they will have torsional strain. Torsional strain. And because of this angle, it will have angle strain also. Because of all these 3, it is least stable. Understand? Steric strain is because of the bulky group, the repulsions will be there. And the bond also very close, no ma. Bond also. That is torsional strain. and because of the angular strain. Okay, so because of these two, the fully eclipsed form is least stable. Okay. Next. So energy order also they will give, you will say. So some compounds are there like diols, 1,2-diol if you take, for that this is exception case. Gauge form only more stable. In case of 1,2 diols, you can take H and H or CH3 and CH3, whatever it may be. Both H also you can take or CH3. This is 1,2 diols. In 1,2 diols, okay, or 3,4 diol here you can say. In diols simply. In diols, we have again 3 isomers, Nama. What are those? I will write now normally. CH3, CH3. This is the first carbon. Next again you can write OH, CH3, H. This is what? Staggered form. This is staggered form. Next, what is the other isomer? You will be having eclipsed. OH, OH, CH3 back of CH3 and H back of H. This is what? Eclipsed form. Right? Staggered eclipse. And one more is there, that is called gauge form. OH, OH, CH3, CH3, H and H. This is gauge or Q form. Now what I told, in general alkanes, which is the more stable form? Staggered form is the more stable form, right? But in this case, what is more stable? Why? Intramolecular hydrogen bond, right? So not only this form, you can take here fluorine also, it will form intramolecular hydrogen bond. I will tell that group. So here which is more stable, children? Gauge is more stable. Gauge is more stable than staggered, than eclipsed. This is the stability order. Stability order. And why it is more stable? Due to intramolecular hydrogen bonding. So hydrogen bonding is very important. Many of the concepts it will come. In tautomerism it got keto-enol form is more stable than keto form in some cases. Why? Intramolecular hydrogen bonding. Boiling points are more hydrogen bonding. So hydrogen bonding has many applications, right? Some element exists as liquid form because of hydrogen bonding. Acidity also it will affect. So that is important application. Conformational isomerism. So in which case you will get that? Means gauge form is more stable isomer. In which of the following case you will get? One two dihaloethanes also. 1,2 dihaloethanes you write here. 1,2 dihaloethanes. Haloethanes. The stability order. 1,2 dihaloethanes also. Anti-gauge and anti-form is only more stable than gauge, than eclipse. Okay? 1,2 dihaloethanes you can't observe. But here, in halogen, if halogen is equal to F, then gauge is more stable again. Some small exceptions are there. This is called as gauge effect. You will learn in higher class. In 1,2 dihaloethane compounds, which is more stable generally, anti-gauge and eclipsed. If the halogen is chlorine, bromine, iodine, this is the case. But if the halogen is fluorine, then again gauge is more stable because of what effect? Gauge effect. Okay, just to remember that.